everyone, and welcome to this 5-part series, which we are going to have on citizen science. And I welcome you all to this special
Hello
series.
everyone, and welcome to this 5-part series.
Yeah, welcome everyone to this 5-part series, which we are going to have on citizen science. Now, the purpose of this series is basically to encourage common people about the scope of participation in various citizen science projects and to encourage people to actually participate in the scientific process. Now, many of you all may not be aware, but there are various citizen science projects which are available in which a lot of people are engaged and have been involved in. And we were going to actually talk about them one by one. And I have a collection of friends over here, all of whom are going to tell you about various citizen science projects in which they participated. And we invite you all also to be part of this attempt of citizen science. Now, we want to give special acknowledgement to Sovan Acharya sir, who has been a big leader in citizen science projects, specifically in India. And a lot of the people who are going to talk today are people who have worked with him, who have learned from him, and who are still learning from him. And hence, we are all very grateful to all the support that we have got from Sovan Acharya. Now, today the specific one we are going to talk about is, I will tell you, today's is about asteroid search. So, if you actually see, I'm going to show you asteroids. We actually have a whole program today in which we will talk to you about, so you can see the asteroid search campaign. This is the IASC, and today's webinar is specifically focused on this. And we are going to talk about how do you actually join this international project, how do you analyze real telescope images to discover asteroids. So for this session, for the first part, I'm going to invite Amrutanshu Vajpayee. And Amrutanshu Vajpayee is the national coordinator of the Saptarishi India VIPNet Asteroid Search Campaign under the International Astronomical Search Collaboration. He's an amateur astronomer, astrophotographer, trained science communicator by Vigyan Prasar, and a trained science documentary maker. So Amrutanshu is first of all going to tell us about this campaign. And later on, as we proceed, we will also show you the procedure, what has to be done in this, and how could you actually participate in the activities, right? So over to you, Amrutanshu. We'll talk about the asteroid project.
Yeah. Thank you. Thanks a lot, Priya ma'am. And at the outset, I extend my wholehearted thanks to the esteemed organizers and the facilitators for today's session, Priya Hassan ma'am and Dr. Najam Hassan and Srishti Astronomy. And of course, the person who is the weaving thread for today's program, Shri Sovan Acharya ji. So I hope that everything will turn out well in this short journey of 40 minutes, which we all are going to have today on this virtual platform. That will be jointly undertaken by the panelists joining from the different corners of India, who are experienced in their asteroid search in the different domains. So with your permission, kind permission, I just am going to start sharing my screen. And anybody can just tell me if my slideshow is visible to you all.
Yeah, that's correct. It's visible.
Perfect. All good.
So greetings, formally welcome to today's session of this introduction to the asteroid search campaign under International Astronomical Search Collaboration. And this is a joint presentation that's being carried out. You can say I am just the mouthpiece, but there is one more person who has helped me out with this presentation is S.N. Sukumar sir, the convener of Mars India Observatory. So let me begin, because there will be a lot of students who are joining us today. For the sake of the curiosity, that can you identify these objects at the outset when you see them? Because these are a few non-conventional objects which are not, you can say, regularly talked about in the public domain, but whenever they appear, they make a lot of, you can say, vibrations all around the scientific fraternity and even in the common society as well. The first of these objects at the topmost level is the asteroids, The second is, of course, the comets. And yes, the third one is the meteor, that is the scintillating light and sound show. So today we will be concentrating upon the first of the objects, which is seen, the asteroids. So if you have seen some of these objects, say these comets, these asteroids and the meteors, they do present a very beautiful light and a sound show. At the topmost portion, if you are seeing, this is the comet Hyakutake, the great comet of 1996. And the below, which you are able to see, is the comet Hale-Bopp. That was the great comet of 1997. And see how beautiful and the scintillating the view that they are making it appears to us in the, they are the signature of the entire, you can say, sighting. But do you know they have got another side that's being associated with these celestial visitors from the distant world? So let us give a little bit of a serious thought that why just simply photographing them or simply observing them is important, and why this entire pursuit of asteroid search is all about. So let us rewind back, and not rewind back today or say 1,000 years ago. Let's go back, say, about millions of years ago. And this is one of the photographs which evidently and clearly talks about a mass extinction that happened, say, somewhere around 65 million years ago. A distant visitor from the cosmos visited us, an asteroid. It fell on the earth about 65 million years ago, and it led to the mass extinction of the dinosaurs. So sometimes these objects, they whiz past us, and they can be catastrophic in nature also. So the first asteroid that when we started working upon this, deciphering the mysteries of the cosmos beyond the planetary and the satellite observations, that is our moon. So first asteroid was discovered on 1st of January 1801 by the name of Ceres. And just approximately about 107 years after it, on June 30th, 1908, happened a very serious event which happened on near the Tunguska River of Russia, which exploded, and an asteroid, it came over and it exploded on to this very sparsely populated region of Siberia, and it flattened about 80 million trees spread over an area of about 2,100 square kilometers. Now you can just imagine an asteroid of that capacity falling over on a very highly populated region like India, say Lucknow, Mumbai, Kolkata, or Hyderabad, or any other place, New York. You can just imagine the quantum of the casualties that happened. And you know what actually happened was a lot of vegetation. I will request all the people to kindly keep themselves muted. So the thing is, what actually happened was it flattened a vegetation of about 80 million trees in the forest. And now you just transform that region from the eastern Siberia to the place where you are living, the highly densely populated. So what catastrophic measures they can bring about? So some of a few prominent asteroids that have been discovered, and these are the 4 largest asteroids, the Ceres, Vesta, Pallas, and Hygiea. And so this is one of the reasons that these asteroids, they keep whizzing past us. So we need to keep a track of them. And how do we need to keep a track of them? How can we keep a track of them when we know them? So first of all, to know them, we need to know where the places are. And to know where the places are, we need to find them. That is the process of discovery. Hence, this primary pursuit of the asteroid search. One of the important another objectives is the human population and its needs. They are ever expanding, ever increasing in the ever progressing world. And in this age of digitalization and where we are just focusing on progress and development, the resources of the earth, they too are limited. So we need to find out a few new repositories also, which can serve the way to satisfy the human needs of the future. And of course, there are a few asteroids that really are the good repositories of a few things which really can be, you can say, source of utilization for the human race in the coming days. So we need to study them. And then, of course, when you are sending your space probes, say for the outer space, millions and billions of dollars are at stake. So one unwarranted collision at any body that is in the space coming from somewhere else, it is not called for. So we need to be very much aware the trajectory and all those things that we are planning. And yes, of course, to know, there is a very deep question which has been always questioned by the philosophies all across the world. Who am I? Now this who am I, or this evolution of the this evolution of the solar system, it really can be deciphered by these unpolluted bodies of the solar system. So this is the importance of the asteroids or the comets, in fact, or for that case the meteors also, because they not simply are the light and the sound show. Not only they are the catastrophic dangers, but they are the potential source of telling who we are, how the life originated, and what all are the important facts that are associated with them. Now, there is a very common picture that's being associated with the solar system, that sun followed by space, Mercury followed by space. There is nothing in between. Earth and moon, nothing in between. Mars, nothing in between. Jupiter, and all those things. And yes, of course, we know between Mars and Jupiter there is something which is known as asteroid belt, which we always talk about. But the real picture, actually, this not is when we zoom it out properly, though these both the pictures, they are not at true scale. But the thing is, even the space is crowded. Here and there are a few distant visitors, like which you can see the red marks, the Apollo asteroids, the Trojan asteroids, the Amors are there, the ATRs are there. There are different varieties of asteroids that are present at the different specific regions. So and out of these, if you can just see these Apollo asteroids, they do tend to cross the orbit of the Earth also. If you can see, they are the Earth crossing orbit asteroids. So they can be potentially hazardous to us. So that is why, because of the variety of that is in the scope for these asteroids, because they have got different shapes and sizes, from very spherical to very irregular, from minuscule of a size, that is a small shaped rock, to minor planets. I request the participants not to annotate their screen, so else I will have to clear all the drawings. Yeah, sure, because it interferes with the flow of the talk. So the thing is, what happens is, there are different varieties that are in the offering, that are in the store, courtesy to these asteroids, whether it is the shape and the size, or whatever it is, whether it's the appearance, whether it is the metallic character, and all those things that really are associated with these asteroids. So it opens up a real new world of expectations for us. So that's why it's very much important to study. And these are Apollo asteroids, and about 2,600, they can be potentially dangerous. That they have, out of those 2,600 asteroids identified, about 600, these all are approximate figures, which can be potentially dangerous. So that's why we need to study them. And this is what it actually happens when an asteroid or a substantial object, it falls over the Earth. If you want to just see the way in which the grandeur, or the, you can say, the amount or the quantum of the damage or the extent of the making, which really can be done, is I will annotate it for you. At the top left corner, which you are seeing a white body, it actually is a resort. And this spiral sort of a thing which you are seeing, which I have just earmarked in the red, it's actually a road. So you can just imagine the size of this impact crater in comparison to the resorts and all those things. The second picture which you are seeing, it consists of an asteroid about 10 meters wide in diameter, and you can see the human extent in comparison to the size of the asteroids. So size of the crater, actually, sorry, not the asteroid, the crater. So there lies the importance of studying them. And you can just see, actually, people, they sometimes, my fellow speakers do hate me, because one slide I always bring, which is little technical, but don't worry, I am not going to, you can say, elaborate it or speak much upon it. You can just imagine, I just have brought, because I found it was interesting. Say these are the events that do occur in a spacing of a time. On the y-axis is the time scale, and the x-axis, it is which I found in the Pearson's book, it is the TNT equivalents of the energy that's being released. So the atom bomb that was dropped on Hiroshima, which caused a casualty of about 90,000 people, or about 90,000 to 150,000 people, it had about 15 kilotons of TNT that was being released. So you can just imagine what a global catastrophe can really be in. And this dinosaurs extinction, it really happened 65 million years ago. So going by that time cycle, one of the major disasters is approaching. So that is why, not to create a fear psychosis in the minds of the people, but the thing is, we need to be very much aware what we are surrounded by in the atmosphere. That's why the need of this institutions like IASC and Asteroid Search Campaign. IASC or IASC is International Astronomical Search Collaboration. And these are a few primary institutions which really collaborated in the beginning to form this IASC. Now this family has increased. Now what actually this IASC or this asteroid search is about? It's a citizen science project which gives you high level great data with participating nations, or in fact the participants all across the globe, as it clearly can be seen over the sky. And the important thing is you get the high grade astronomical data free of cost. Now, there are different institutions that are involved, but there are a few prerequisites to the glory as well, which will be talked in detail by Sugumar sir, Amoli Kakkad ma'am, and Dr. Mela Mitra, who are the fellow speakers. Now, I'm approaching to the final portion of my talk. There are a few basic pre-requirements that are needed for you to get yourself enriched into the annals of the history. First of all is a system that you require. I will caution you, mobile won't work while doing this analysis. Secondly, you need a stable internet connectivity. You need an Astrometrica software, the demo you shall see in the coming times. And then, of course, the dedicated time and perseverance. One picture speaks equivalent to 1,000 words, hence the picturization of all the 4 pillars on which this entire pedestal of asteroid search stands. This actually is the flow of the IASC program. If you can see, the data that's being taken up, it is from the Pan-STARRS Telescope Observatory of Hawaii. The images, they are being collected in a specific format, which is known as FITS format. Just like we have JPG files, TIFF files, there is something which is known as FITS files. And these images, they are put onto your team folder with the help of Hardin-Simmons University, another collaborating premier institutions of IASC. And then what happens is, if you are participating as a team, you download it on your system. There is no intermediary between you and the data. You are the analyst, you are the recipient, you are the giver. IASC and Hardin-Simmons University, Catalina Sky Survey, they are the providers. I request all the people to kindly keep themselves muted. Then what happens is, as a team, as a member, you download the data, you analyze them, and you make a claim to IASC. They reanalyze your claim by taking the photographs of that region again, and with the help of telescopes like 2-meter Fox telescopes. And then once they are confirmed with once they have cross verified your claims, then what happens is they give you your object as the level of preliminary detection. Preliminary because it is discovered or detected at a preliminary stage. Not much is known about its orbit, about its characteristics, its inclination, eccentricity, and all those technical things that will be studied in the future. And all these are submitted to the body Minor Planet Center at the International Astronomical Union. This is the paraphrasing of the entire process which I just have told. And once you get the preliminary status, now the monitoring starts. And upon the further monitoring, when the orbit is established, your detection which you have done in this IASC, this analysis part, it gets upgraded to stage number 2, which is known as provisional discovery. Now your detection has become a discovery. And then after the further analysis, when the orbit is established, other characteristics, they really are studied, which are technical in nature by the researchers, by the serious observers, professional scientists. Then your object detection is given a number. It is known as a numbered asteroid. And once it is a numbered asteroid, the day will not be far when, as a citizen scientist, your time comes, you will get to name the object. Just imagine your name imprinted into the history books of astronomy as a discoverer. So it offers a very quantum of solace for the, you can say, the days to come. This is just a glimpse of your software companion, and which will be taken up by Mila ma'am, the coming speaker. And these are a few smiling faces courtesy to the IASC. And to the top left is one of the trans-Neptunian objects that were discovered by the students from Taiwan. And they are all the participants from the different corners of the globe. And this is one of the screenshots which I have just taken from the ongoing IASC asteroid search campaign. This is how your entire diaspora of detections is being shown, with Pan-STARRS Observatory, Catalina Sky Survey, Hardin-Simmons University under all combining together, with NASA as a partner to this an international astronomical search collaboration. These once you do you can say discover or detect a few things, your detections, they are being recognized by IASC also. They sometimes they do put your smiling photographs, analysis, and all those things on their website also. This is how a list is published at the preliminary detection level. Once your entire asteroid search campaign spanning 1 month is over. This entire period is of 1 month in which you detect the preliminary asteroids. This is one of the screenshots which I have taken from the list of the Mars India Observatory. This is another preliminary screenshots which I have just taken from Ignited Minds Sky Saptarshi India Asteroid Search Campaign. And these are a few smiling faces which I have received from Sukumar sir, our Sovan Acharya sir, and from the conveners of that is our Tushar Purohit sir from Saptarshi India. So these are the way in which you receive the certifications at the preliminary level. Now, once your preliminary detections are over, these all are upgraded to the provisional discoveries. And I will just flip it over. See, this is a poster which I received from Dr. Mila Mitra of STEM in Space. Their students have done wonderfully, exceptionally well over the past couple of years. And you can see the proud smiling faces who were the provisional asteroid discoverers of the last year. And I am wishing all the students luck and success so that they become numbered in the future. And with these words, I just would like to give a special word of thanks to all the people who were involved in making this, you can say, this presentation a success, beginning with Dr. Patrick Miller, the Director IASC, Cassidy Davis, ma'am, the coordinator, Dr. Arvind Ranade, Mr. Tushar Purohit, Sumit Srivastavji, all the entire Mars G collaborating and Saptarishi Vipnet family, and the facilitators of the session, Dr. Priya Hassan and Najam Hassan sir, and of course the collaborators, Sovan Acharya sir, Mila Mitra ma'am, Amit Raka sir, and one person deserves a special mention is Mr. Sunil Dabas, who is not with us anymore in this mortal world, and he is somewhere residing in the stars, but he was the person who brought us, myself personally speaking, at this level of asteroid search. With these words, I thank you. For more details, you can just log on to this website of IASC and cosmosearch.org. And of course, the more details and email and all those things of Sovan Acharya sir, they will be shared by the co-speakers and facilitators in the coming period. Thank you. Thanks a lot. I am stopping the presentation and sharing of my screen.
Thanks, Amritanshu. Thanks so much for explaining what is the importance of discovering asteroids and how does this go on. So just for the benefit of the participants, I would like to mention we will have these short presentations by various speakers, and we will, after that, once the presentations are over, that's when we'll take questions. But if they are very urgent, you can write your questions on the chat, and finally in the end, everybody will, the questions will be taken. So please keep the questions on, and we'll be taking that in the end. So thanks a lot again, Amritanshu. And now we have our second speaker, that is Dr. Mila Mitra ma'am. And Dr. Mila Mitra is the co-founder and academic head of STEM in Space, which is an educational organization that encourages education through space domain. She has worked at NASA on missions such as Cosmic Background Explorer. She's an active science communicator and has coordinated projects such as Asteroid Search Campaign for more than 10 years, as well as Globe at Night, Asteroid Day, etc. She gives regular public talks, writes a monthly science column in media, and she's the one who's going to give you more details about the Asteroid Search Campaign, specifically with a demo of the software which you would be using when you are participating in this campaign. So Mila ma'am, welcome, and you can share your screen, or yeah.
Again, hello everyone, and hello. I welcome all the space enthusiasts who have joined us for this session today. And again, thanks to Priya ma'am, to Srishti Astronomy, to Shovan sir for taking this initiative. So I'm looking forward to sharing with you today how this process works. So Amritanshu just described what is IASC. So I'm going to tell you in brief, because it's a demo of how you would log in and do this process if you signed on to do it. So it's going to be a little quick. So let me start off. So up here, I have the web page for IASC. And this web page is iasc.cosmosearch.org. I hope you can all see it. Okay, so this is a web page. And the first thing you need to do, because at the end of it, you'll all ask, how do we join this? The way to join it is there's a button right here on the top page that says register. So you can register And if you scroll down, you will see pictures of participants, but you will also see upcoming campaigns. So every month, there are several teams from around the world that join the campaign. So currently, you can see there are some going on, including the International Asteroid Search Campaign. So once you register, you'll either be put in the International Asteroid Search Campaign or one of the other ones that are ongoing. And sometimes some of us, like there is a STEM and Space campaign, there's a Mars G campaign. So there are different campaigns you can join. And again, I'm proud to share here that CB Devgan also now has a memorial search campaign named after him. He was also a very well-known science communicator and astronomer. Okay, so once you register, you'll have a login page. So I'm already logged in. So what happens if you have a login page? Once you log in, once you register, you will get a mail from IASC with your user ID and password that will help you log in. So then you'll go to the campaigns page and you will see the current IASC campaign and you will be part of one of them. So right now I'm going to log in to the Mars G campaign, which is led by Sugumar sir. And I'm going to log in through the SA Citizen Science group. But again, you will have a team name and you will be part of a specific campaign. So you should only go to that page. So right now I'm demonstrating it. So you will not be able to log into this. So once you log in, you will find that there is a quick start guide that you can download that gives you the instructions. There is a configuration file because, and again, please do not annotate. Yeah, I'll have to remove this annotation, but yes, there is a configuration file because each telescope, and this telescope is Pan-STARRS, it's PS1, Pan-STARRS 1. So you have to update the configuration in the software. So there's a configuration file that you will have to use here. Okay, so what do you see? Amritanshu, can you see if you can remove this annotation? Or
Sure.
Priya ma'am?
Ma'am, what you can do is you just open your annotations
Yeah.
tab and
Now
then
it's here. For a while it was stuck, but I can see it now. Yeah. Okay.
It's out.
So yeah. So once you go to your web page, you will see some image sets that you can download. So let me click on any one of them. And when you start off, you'll just have one. As you do your, as you submit reports, you will have more. So when you download, it downloads as a FITS file. Sorry, not as a FITS file, as a zip file. Okay, so it's a zip file, which you'll have to unzip to get FITS files. And I will show you that on my desktop in a little while. So you do get about 15 to 20 or maybe even more data sets. The other thing you see on this panel is the citizen scientists who are part of your group. Now, this is part of a very special group, the citizen science group. So there are many participants right now, but usually your team would have only about 2 to 5 participants, and you can put in their names. And finally, there is a blank section, which is the MPC report, MPC standing for Minor Planet Catalog. And this is where you will submit the report. So now that you've downloaded a data set, you will go and analyze it. But before I show you that, how do you get started on this? You would go to the Astrometrica page, Astrometrica link of this website. Under here, you see 3 things that you need to download. The Astrometrica software. So for this, there's a setup and you can download it. It's an executable file. It will you click on it and it will start installing. Then there are some Astrometrica guides. So there are 4 guides and that will tell you how to install and how to run the program. So whatever I'm going to tell you now very rapidly, you'll be able to see all the steps in the guides once you register. And there are also some practice image sets. So basically IASC gives you this so you can set up your software, read the guides, and have the practice image sets ready so you can have it all set up before you participate and start getting real data. Okay, so I'm going to now start showing you the software and how to use it. Okay. Yeah, again, please do not annotate. Okay, so once you download all these things, you will have a quick start. You'll have the Astrometrica setup, which is an executable file. You will have some guides. I've unzipped these, and I hope you know how to unzip. I'll show you that for one example. So the unzip, once you unzip the guides, you'll see that there are 4 guides. There is a README, which tells you how to install. Then there's a guide to use the Astrometrica, and another guide on to guide you on how to recognize true signatures versus just things that are blips in the CCD imaging. Okay, so you need to know how to distinguish between those. There's also a lot of practice data sets. So these are all zip files. So how do you unzip? All of you know that, but let me just show you. You can unzip it by clicking extract all, and all your all your laptops would have different ways to extract it. Okay, so this is how you do it, but I'm not doing it now because I already have it uninstalled or extracted. Once you extract it, then you will see that each data file that you downloaded and extracted, there are 4 files inside it. So what are the 4 files? These are FITS files. These are not JPEG, not PNG, but FITS files. And Amritanshu mentioned that these are a scientific format and they retain. Okay, so hopefully you can see my screen now. This is the, so when you open the zip file, you'll see 4 files. Why 4 files? Because it's a time series. It's the same part of the sky taken at time intervals. And that is the main concept, because the concept is that if there's a moving object, such as an asteroid, then if you blink these 4 images, you should see them move. So that is what we are going to be looking for. We are going to blink these 4 images that are time series and try to look for something that is moving. And if they are, we can say maybe they are a suspected asteroid. Okay, so once you've downloaded, you are going to go ahead and install Astrometrica, but I'm not going to do that now in the interest of time. I'm going to open the Astrometrica that I've already installed. And again, just to note, this takes a bit of time to come up, and that's a good thing because it uploads the MPC catalog. What is MPC? Again, the word MPC stands for Minor Planet Catalog. That's a large database of all the objects that are asteroids, comets that have ever been discovered. They're all listed there. So every time you load this, it updates it to put in the newest ones into the catalog. Okay, so this is Astrometrica. It's a very advanced software that does all kinds of things. It will just start you off and you say yes. Okay, so astrometry, the word means measurement of brightness as well as positions. So that's the word, and that's a lot of stuff that you can do with the software. But I'm going to show you a specific goal. So that's what we are going to do. So we are going to open up. Remember, I downloaded an image set, but I'm not going to work with that. I'm just going to work with one of the practice data sets. So I'm going to upload that. And like any other software, you start by uploading your images, or uploading your Word document or PPT, something like that. So here, I'm going to go to File, Load Images. And remember, you don't have to remember the commands because you can find it in the guide later. Okay, so here is where I unzipped a practice data set. And there are 4 images in there, or 4 files in there, 4 FITS files, which are flexible image transport system. I open them all together. So now I have 4 images. And what do I see? In each one, it's the same part of the sky you can see. Okay, so if I click, you can see the same part of the sky. And right on top here, it's an artifact. You can ignore things like that. Those are false signals. It's got saturated in the CCD camera of the connected to the telescope. So you ignore things like that. The rest of it are all celestial objects, and we are going to blink these 4 images. Again, these 4 images are a time series of the same part of the sky, and we are going to be looking for moving objects. But before we can do that, we have to do some quick steps. The first step is you have to put in the right configuration file. Okay, so the right configuration file is at the bottom. You see the word. If you look at the
excuse me, ma'am, we have lost your screen.
Okay, yeah, sorry.
Yeah, you need to reshare.
Yeah, I'll do that. Okay, you can see it now, right?
Yes, ma'am.
Okay, so at the bottom right-hand side, you see a word called ps1.cfg, but most of you, when you open, will not have the right configuration file. So what you do is you have to upload it, because a configuration file gives you all the details about the telescope, like the, about the mirror and all that. So you have to update it. So the way you do it is open the settings window, do an open, and you will go and find your PS1. And if this is not the latest one, then you will download the latest ps1.config, and CFG is config, and you will say okay, and make sure, I'm just saying no right now because mine is already updated, but yes, you will update the config file first of all. Secondly, you will do a step that's called astrometric data reduction. So what this does is you just go ahead and say okay. What this does is it matches your field of this image to a reference star catalog. And don't worry if it's saying not responding. It is a very time intensive, bandwidth intensive task. So it does take a bit of time. So I'll tell you what it's doing. It goes ahead and looks at a reference star catalog and matches all these reference stars to your 4 images. And with that, it tries to set a coordinate system. Okay, so I hope you can see it. Right now, the exercise I did of data reduction has actually given me back a table. And this table has some data. For example, the first line says that 227 stars were matched. Out of that, 33 reference stars were found to match it. And then it tells you what is the fit order to which it could match it in terms of photometry and also in terms of distance. So this reference star guide was used to set up the coordinate system of your object. And again, please, Dhritisman, please do not annotate, because these objects that you're putting green on are going to be very important for people to see. Okay, so I'm going to stop this table. It was just a statistics. This means that the reference star catalog has been properly aligned. The images have been aligned to the reference star catalog, and the green dots indicate the stars that were matched in the green with the reference star catalog. So there's one more thing you need to do before we blink, which is you click on something that's called known object overlay. Okay, so this goes through the catalog, the minor planet catalog, MPC catalog, and finds, are there any objects in this field of view of the image that have already been discovered? And if the answer is yes, then it's going to put up a mark, and there's a red mark here that tells you where the objects are that it has found. So now we are ready to blink it. Okay, so the true signature, to look at true signatures. Okay, so let me start blinking it. What does blinking do? It's like an animation. It rotates image 1, 2, 3, 4. Okay, so now it's going to start blinking. and it's going cycling through image 1, 2, 3, 4. Okay, so the signature of a true asteroid, what are we looking for? We're looking for moving objects that move in one direction in a straight line. It can be a bit curved, but it should be in one direction, almost a straight line. It should be a constant speed. And when we explore it more, it should have a constant brightness in between the 4 images. What does that mean? If it's a moving object, as opposed to just a artifact, then it should be cleanly moving in one direction. So we're going to look for visually for things that are cleanly moving. And for that, you can take the help of zooming, scrolling. Okay, so we are going to do that. And I have already found one because it's a demo. So I'm going to indicate this to you. This practice data set has one object that I've already found that's moving. And you can see this object here. You can see it moving between the 4 images as the 4 images are blinking. 1, 2, 3, 4. It's quite bright. Unfortunately, the objects you'll try to find are not as bright. They'll be very dim because the brightest asteroids have already been discovered. So you'll have to look carefully. But yes, I'm seeing one here. So if you see one, then what do? You try to record it. Okay, so now again, you can see the object that's moving. Look at it carefully. Now I'm going to stop it. Once I started the blinking, there's a screen that came alive, which is the stop button, play button. It's like a video recorder. Okay, so I'm going to do the stop button. Then I'm going to forward it to image 1. Make sure you're at image 1. Then you click on this object. Okay, so we've already visually seen the 2 signatures that the 2 signs of a true asteroid, which is it's moving in one direction and constant speed. Now you click on it. Okay, so there's a new window that comes up, and it gives a lot of information. So the window on top shows a small circle, and that small circle is the object that you have located, marked in red. Just below that, there's information, which is the name of the FITS file, the time and day when it was observed, and also the RA and declination. For those who don't know it, RA and declination, right ascension declination, are the coordinates or the location of this object. And there's also a term called R, which is the magnitude or brightness. So the RA and declination will change between the 4 objects because that's what we're saying, the object is moving, but R should not change. There is an error within error of 1. So if this is 18.4, the next one should just be above 17 or less than 19, but not change by more because it's the same object. Its brightness cannot change in such a short time. Okay, now come back here to the right-hand side, right-hand top. There's a red curve and white dots. Okay, so basically, again, I request everyone to mute yourself because my voice is coming as an echo. Yes, so the white dots line up well with the red curve, which is the red curve is a sign, is a Gaussian, curve that shows that it is a real signal. And the last thing you have to check is this term, which is called SNR, signal to noise ratio. You have to make sure your signal is brighter than your background by at least some factor. Otherwise, how can we claim it's a real signal? So usually they say that we should try to check for SNR that is 5 and higher. And you make the judgment call. If it's 4, but it's got all other good signs, then you pick it. But below that, it's doubtful if you can say for sure if it's an asteroid. Okay, so this one, I would say I'm accepting it as an asteroid. If you do, then you have to give it a name. What you do is first click on this object designation, and you can check if it's a known object. If it's a known object, then the first line, which is the closest known objects, will show a DRA and a DDE, which is a difference in right ascension between what you have found and the known object. If it's close to 0, that means you found a known object. But in this case, it's not close to 0. So I will name it as a new asteroid. Otherwise, you would have accepted that name itself. Okay, so there's a convention to naming, and you have to stick to this convention because the results or your report is read by a software. So it needs to make sure that you have the correct format. And the format is 3 letters and 4 numbers. So it's a 7 character. So you can name it any 3 letters, A, B, C, or MIL. In my case, I'm naming it anything you want. It won't count as a discovery, so it doesn't matter what you name it, but it has to be 3 letters and 4 numbers. And the next asteroid you name, do go ahead in the sequence. Name it 2 or 5 or 10. Don't come back and name it the same thing, but it can be part of the same sequence. Okay, so I've named it now. And now you see it's marked in pink. Now the next step is easy. I have to redo this step for all the 4 images, because that's how it tells you how the object is moving. Okay, so remember, you have to mark it in all the 4 images, and look, just check that the R, the magnitude, again, is pretty close to what it was in the previous one. And you've already checked the SNR and the white dots and the curve. They should lie. If the white dots don't lie on the curve, it means that it's just a fluctuation. It's not a real object. Some cases don't lie as well as this. They are scattered, but there should be some pattern to it. Now I'll name it the same object, same name, not a different name, because it's the same asteroid. Okay, so I accept it. Then I go to the next one. Again, so I'm going through it rapidly in the interest of time, but you should do it very carefully and diligently. Make sure you have the right object that you're marking in all of them. Okay, so now I have it marked. So now I can again blink. I have 1 asteroid selected. I can again blink, start blinking, and see if there are more. And in fact, in this field, this practice data set, there is at least 1 more. Okay, so what you would do is, again, if you find 1, okay, so I found another 1 here because I already know it's there. So you can go ahead and again mark this also. So I'm not going to do that. What I'm going to show, so if you marked it, let me show you how you would do it. You would again go to image 1. And now you would give it, after you do all the checking, make sure it's not a known object, then now you would give it a different name. Okay, so, and you would do the same in all the 3 cases. Once you're done with the asteroids that you want to report, then you go ahead and submit your report. How do you do that? You go to File, View MPC Report File, and now look, it's going to show you the report you have generated. Okay, so the report has a header. It also has 4 lines per object. It should have 4 lines per object. So what do each line has the right ascension declination, which is the location, and it also has the magnitude. Okay, so now I have 4 lines, so I did a good job. In the second asteroid I was going to mark, I just did it 1 time, but it really should have 4 lines because the software will compare how it's moving. Okay, so this is when you're done with the report, you can copy it with your Control-C. You can save it in a notepad if you want to work further on it, if you want to edit it, and then now you are ready to submit it. So I'm just going to show you the final step. Okay, so in the final step, I go back to the campaigns where my account is, or your account will be. This is not my account. I'm using the Citizen Science account. So thank you for letting me use it. So you go back to your account and you go all the way down and you have to say submit an MPC report.
Yeah, all fine. You need to share your screen. It's fine.
I am sharing. Can you see it now?
Yes, ma'am.
Yes, all good, all good.
Okay. So all you do is select the image set. Do select the correct image set name. that you downloaded and worked on. Select the citizen scientists in your group that participated in that particular analysis, or mostly you would select all your names and then you just do paste, and then you're ready to submit, right? So this is how the whole process goes. You look for blinking objects and you first you download it from your campaign page, you analyze it with Astrometrica, you read it in, blink them, look for moving objects, create a report of suspected moving objects and submit it, and keep on doing that for the number of times you get new data, right? So that's the procedure, and I hope, I know I went through it pretty fast, but if you register, you will get the training and you'll get the guide so you can go through it. And again, thank you everyone for listening to me, and I hope that was useful.
Yeah. So thank you, Mila ma'am. Thanks so much. And we'll have to now continue with our thing. We have two more speakers, and that's Amoli Kakkar and S.N. Sugumar. So Amoli Kakkar is a homemaker who's now a very passionate amateur astronomer. She's an avid astrophotographer and has been featured in AVSO. This is the American Society for Variable Stars Astronomy. And she's taken part in several citizen science projects with discoveries to her credit. She also trained students for the IASC Asteroid search campaign. She even trained me when I tried doing the campaign. And we also have with Amoli Sugumar sir. And Sugumar sir is the convener of Mars India Observatory and the Mars SG India Asteroid Search Campaign under IASC. He's an amateur astronomer and astrophotographer. So both Amoli and Sugumar sir will talk to us now about the asteroid search campaign. Yeah. So.
Thank you so much, ma'am. It's a great pleasure.
Yeah, and I should mention, sorry Amoli, but I should mention that thank you so much Amoli. Amoli's actually got dengue. So with her dengue, she is still, got the courage to talk to us. So thanks so much Amoli. We should acknowledge your enthusiasm.
Thank you so much, ma'am. It's really an honor to be associated with such a wonderful group of people. And I think so this platform is such a platform, the Citizen Scientist platform is such a platform where you can just take out your hidden scientist and do science sitting at home with a few minimal requirements like a laptop and a very good internet connection, of course. And I think so I was very fortunate enough to be associated with Meela Mitra ma'am, Sovanacharya sir, who also guided me through different citizen scientist projects. And I think so Meela Mitra ma'am was the first person who introduced me to IASC, that is the Asteroid Search Campaign. And the day she introduced me, and till now, it's almost 2.5 years, 3 years, it has never been looking back. I am such passionate about doing the asteroid search campaign that it's almost a year that I have been regular in the participation of the asteroid search campaign, as well as I take care of guiding a few of the students if they require any help with the proper guidance of Meela Mitra ma'am. Thank you so much.
Thanks, Amoli. We now have Sugumar sir talking to us, and then after Sugumar sir, we'll be open to questions, right? Yeah. Okay, sir.
Good evening, everybody. I'm S.N. Sugumar, convener of Mars India Observatory and Mars India Asteroid Search Campaign. And thank you, Priya Madam, to bringing me into this forum and talk about the Asteroid Search Campaign. And first of all, I would like to thank my departed friend, Sunil Dabas, for having brought me into this Asteroid Search Campaign. And thank you, Sunil. And what is this Asteroid Search Campaign? It is nothing but helping the scientists See, there's so much of data available with them, and they are unable to process everything, and they don't have much time. And it is our responsibility and duty to help those scientists in finding and detecting the asteroid, which are likely to be a harming one, which might hit the Earth if not traced properly. That is the main reason for this asteroid search campaign. And of course, we have so many people doing this one, and there are a lot many people who can help whoever is coming in. And I hope and wish SI Citizen Science Group a wonderful time in this campaign when they come up with the teams. And the people who are watching here in this program, I welcome you all. Be a part of this, and you can walk the beach along with us with hands spread over all over the place, right? Thank you very much. Be there. We'll be there to help you. Thank you, ma'am.
Yeah. Thank you, Sukumar sir. And now we'd like to open the floor to questions. So please, if anybody has questions, you can either write it on the chat window, or you're most welcome to even unmute yourself and ask the question, right? So, yeah, so the first question is from Jayashree Seal. I'll just read it out. And she says, while working on Astrometrica, is it necessary to have constant internet connection for blinking and identifying the asteroids? Maybe Mila ma'am would take the question.
Yeah. Thanks for the question, Jayashree. And yes, you landed on a very important point, because you indeed need a very good connection, and for blinking and for that reference star catalog, for all those steps, you do need a good internet connection. And sometimes people don't have a connection, and so they have errors. So yes, you do need.
Yeah. Thanks. What about more questions? Do we have any other questions?
And to add to that, I would also, I think Amritanshu mentioned, but you do have to have, this software doesn't work on a Mac system. So either you'd have to have an interface on your Mac system to enable a Windows or something like that. But otherwise, you'll have to have a laptop or something else to make it work.
I'd also like to repeat another question which I'd asked you earlier, but I'll do it for the advantage of participants. What would you say is the minimum age for children to participate in asteroid search campaign specifically? So
I will also, from my viewpoint, because STEM and Space does this conduction with so many schools, I say that we need at least, students who are in grade 6th or higher, because as you saw, it was a little bit technical and you have to have the concepts. But, some of you might think that it's okay to have a little bit younger students if they're, savvy with the computer technology.
Yeah, thanks. Hemant asks, what should be the computer configuration for Astrometrica software? So like Mila ma'am said, Windows. Does it work on Linux?
Amritanshu, do you know if it works on Linux?
By default, when we download this Astrometrica is an exe file, executive file. But yes, of course, it does not work on MacBook. Now, if a person who is proficient in operating these softwares like Wine Server on the Linux, you really can make this Astrometrica, and for that case, any Windows software operate upon the Linux. But the thing is, you have to be efficient and proficient in both the terms while operating this exe file, because one part of that is missing. Even for the Wine Server, it will create a problem for you. And regarding the configuration of the system, say if you can say we don't require any hanky-panky 1 lakh or 2 lakh systems for that. The basic requirements is 1 GB of the RAM is more than enough for this Astrometrica to operate, because it does not use too much graphical interface. And the executive file is simply, which Mila ma'am just showed you the online way how to download it. It's 8 MB. And when the file which was being built, when you saw a black screen like a DOS type of a thing, those who have operated that DOS system, it takes about say 65 MB of the data when it updates the MPC ORB, that is the Minor Planet Center Orbital Database file. So even if it is a general, you can say very low type of a configuration with 1 GB RAM and the basic requirements available with little space in your C drive, it will operate. The thing is that first query which stressed upon Mila ma'am answered it in detail is a stable internet connectivity from the point of technology. And second thing is patience, discipline, and perseverance from your part.
Additionally, if they're students, mostly they would be working in teams. So you have to collaborate with them too, because teamwork, because you can only submit one report per data set. So you have to work with your teammate.
Yeah. Thank you. Joyshri Seal asks, how much effect would this citizen scientist campaign affect my future career? Are you referring to a future career in astronomy, Joyshri, or?
So what I will tell you because I've known several students. So basically you do get a participation certificate from IASC, and IASC is partnering with NASA on this. So you get a certificate with IASC and the NASA logos, and Amritanshu showed pictures of those certificates. So that does help in your resume that you're building up, and you can say you've done this project, you can talk about it. So it does help a little bit in showing you that you've taken part in a scientific and technical international project.
And ma'am, I would like to add upon that if you make a discovery, it would definitely be
Right.
a good point in your CV.
Yes. So if you discover, it will be a lot of it will help you a lot. It will give you a really bonus point in your CV.
Yeah, and one more add-on, that is because since astronomy is not a part of the curriculum at the school level, so if you are going at a higher level to pursue this course, as a matter of fact, you will be one step ahead of your you can say companions or who are your batchmates and all those things, because you will be very much efficient and proficient in the terminology, the linguistics, the jargon of astronomy if you work upon such sort of projects. Especially each scientist is a citizen, but within each citizen also resides a scientist. That's the spirit.
Thanks, Amritanshu. That was very well put. We have another question. Just a sec, which is here. Okay, Deepa Pratham is asking whether the procedures or processes are written in a guide, because sometimes we'll have to read it and do long procedures which are hard to remember. So.
Yeah, so that's what I showed you. If you take part in this campaign, of course, I went through all the steps, but there are the guides. So if you take part in this campaign, the web page has guides you can download, and they will walk you through this step by step, so you can revise all these steps.
Yeah, there's tutorial, there are training files, there's a lot available. So once you're part of it, you can use help even from your teammates, right? Because you're part of a team, and you can always ask your teammates. That's what I did when I was part of it. I would keep asking Amoli ma'am or somebody else for hints as to what to do. Because yes, you may do, I mean, even in my case, you forget the procedure, what to click, what not. So anyway, since you're part of a team, so your team is also there to help you other than the online help, right? So that's all there.
And of course, all of us here are also ready to help you. We are very happy to help you, because we are all part of this SA Citizen Science group, and we would be happy to answer any of your questions later on as well.
Yeah, so we have a running WhatsApp group, which is what Mila ma'am spoke about, which is that. So not only will you have your team, but you have another group also which you could be part of and interact with people to find out things, because everybody has a different level of expertise, and definitely they can help you solve your problems. So I don't see any more questions. So probably we'll conclude over here, and we obviously will meet you again next Friday. But before that, I'd invite SN Hassan sir to talk to us about some final comments. And thank you very much to all the speakers of today. Thanks so much for all your help and all your support. And tomorrow, next week we'll meet, and I think it's Zoo Universe, right? I think we'll be talking about Zoo Universe, or it's a surprise. So, SN Hassan sir, you can talk, and this thing.
Hello to everyone. So let me thank Amritanshu sir for his lovely presentation on why we study, what are asteroids, why is it important to look at them, and why is it required, very essential for our survival to trace them, track their trajectories, and the beauty in the whole thing. Dr. Mila Mitra, she gave a very detailed demonstration on sir for encouraging people to join this beautiful citizen science project. And what I would like to add is astronomy has a very strong appeal universal appeal which goes across is you can contribute and participate at professional level in different aspects of astronomy, or even as a school child or a person, homemaker. If you are interested, you can do very meaningful work. And the citizen science project, you can contribute all levels at a professional level. So I would like to thank all, and I'm very, we are missing Sovan sir's presence today because he had been a motivating force behind all this. And I'm sure he'll be with us next time. And as webinars on this, today we had on Friday, we'll have it on Zoom. With this, I'll hand it back to Priya. And we are with all of you to help you, and we are part of motivating you at astronomy at all levels, at amateur level, at professional level. So thank you.
Yeah. So thank you so much. And I'll say thank you to all our speakers. Thank you to everyone. Thanks to the participants for participating. And see you again next Friday, same time, 8 o'clock, on our next Citizen Science project. Thank you. Bye-bye.
Thank you, ma'am.